Let's solve this impulse problem step by step. We need to find the impulse on a 3.0 kilogram object that experiences the force described by this graph. Let's first plot our force versus time graph. The graph shows several key points. At time 0, the force is 1500 newtons. At 5 milliseconds, it drops to 1000 newtons. At 8 milliseconds, the force becomes 0. And finally, at 10 milliseconds, it reaches negative 1000 newtons. Remember that impulse is equal to the area under the force time curve. Mathematically, impulse is the integral of force with respect to time. To find the total area, we'll break this into two regions: a positive area from 0 to 8 milliseconds and a negative area from 8 to 10 milliseconds. Let's calculate the first area. From 0 to 5 milliseconds, we have a trapezoid with heights of 1500 and 1000 newtons. The area is the average height times the base. That's 1/2 times the sum of 1500 plus 1000 times 0.005 seconds. This gives us 6.25 newton seconds. For the second part, from 5 to 8 milliseconds, we have another trapezoid. The area is 1/2 times 1000 plus 0 times 0.003 seconds, which equals 1.5 newton seconds. Finally, for the negative area from 8 to 10 milliseconds, we have 1/2 times 0 minus 1000 times 0.002 seconds, which equals negative 1 newton second. The total impulse is the sum of all these areas. 6.25 plus 1.5 minus 1 equals 6.75 newton seconds. Therefore, the impulse on the 3 kilogram object is 6.75 newton seconds.